Hello there. Welcome to another tech brief. In this session, we will give an overview of what serverless cloud computing is all about and why you should strongly consider it for your business. Please note that we will use AWS as a cloud example for this tech brief, but similar stacks can be built using GCP, Azure, and of course, there are going to be subtle differences in their implementations. While there are going to be some technical detail, this video is intentionally structured like a business case to help business leaders with making the right technology choices. For all techies, we will do a capstone project later in this series where we are going to get a lot more deeper into the technology. And as always, please like, share, comment, and subscribe if you like this video. So, what's in this video? Well, first, we'll define what it is and show how it works through some example scenarios. Then we'll discuss the benefits of serverless against other approaches. After that, we'll take a look at where it can be used and, of course, where it should not be used. Finally, close it out with some steps in implementation and some additional information. Okay, let's get started. First things first, serverless does not mean that your code runs in thin air without any computational hardware. That's simply not possible. Every piece of software needs some hardware where it can execute. Traditionally, we are used to explicitly providing this hardware by means of desktop computers, servers, racks of servers, or in the modern age by defining and configuring virtual machines and clusters in the cloud. In serverless computing, however, we just need to focus really on the business logic and not really worry about where it runs, because the cloud provider will automatically assign the required resources at the time when your code needs to run. So essentially, it is serverless from your perspective to compute your code in the cloud, hence the phrase serverless cloud computing. AWS calls this service the AWS Lambda service, and the piece of code is referred to as the Lambda function. And we will use this phrasing later in this video as we go on. How does it work then? Well, let's understand that through some example scenarios. Let's imagine a scenario where a user comes in either through a web page or a mobile app, or even that user can be a machine user from a different system, and they request some information from your application that requires you to execute a piece of code, the Lambda function, which may take a few seconds to few minutes to execute. In serverless computing, a compute instance, the required hardware in other words, is automatically created to run this microservice or the Lambda function. After creating a compute node or the instance, your code starts executing. While running, your code, this Lambda function or microservice, may access other systems or even create more serverless resources, serverless functions, such as database instance or whatever else is required in order to complete the required business logic. Once it's done with execution and a response is sent back to the requester, the compute instance will terminate itself and vanish into thin air. No more hardware resources now. Your application has just become serverless when it's not running. And you will be charged a small fee only for the number of seconds the hardware resources existed. So essentially, you are really paying only for what you have used. In the long run, this pay-per-use model may turn out cheaper than provisioning, maintaining, upgrading, and all other excitement that come with traditional servers, on-premises, or even cloud. In that example, we have seen a request coming through from the API. The trigger to execute a Lambda function doesn't always have to come from an API function call. Lambda function can be triggered from any other services within AWS. For example, A new message posted to message queue service SQS, AWS SQS service, can invoke Lambda function to process that message. Sometimes you may need to run a piece of code after a new user is created in the database. You can configure data streams known as DynamoDB data streams or Kinesis data streams to invoke your Lambda function to do this. Or maybe you have a need to run code after a document is posted, uploaded, or modified in the storage system. You can configure the S3 events to invoke a Lambda function. Or maybe you just want to run a piece of code on schedule. Let's say like something like 4 a.m. every weekday, for example, maybe just to monitor status of some overnight batch job. This can be achieved using the cron-like scheduling provided in the AWS Event Bridge. We can't cover in every trigger here, but there are more ways to invoke your microservices or the Lambda functions. So far, we discussed how a compute instance would be created when the Lambda function is invoked. Now, what happens if you have multiple requests coming in at the same time then? Well, in that case, serverless computing will simply spin up a new compute instance for each invocation and destroy it after each execution. So essentially, your compute resources will scale to the rising demand without having to pre-allocate all the resources for peak demand. That's pretty neat, but this scaling is not unlimited. Obviously, there are limits. For AWS Lambda, you can have only 1,000 of these parallel instances in a region. That is not 1,000 per function. That is not 1,000 executions per function. That is 1,000 across all functions in a region. Given how quickly these functions run, though, hitting this limit is unlikely. But if you do, there are some function prioritizations and rate control techniques that you can implement, but we'll save those details for another day. Also, you could run into some database concurrency issues with all this parallelism, but that is also a topic for another day. All right, what about authentication and authorization? The APIs need to be very secure because they sometimes carry very sensitive data. For this, you can make use of any identity provider such as AWS Cognito, where the users can authenticate themselves and obtain tokens. This token, usually a signed JWT token, is sent in the header of the API request, and the microservice can then figure out the authorization based on the claims carried in the token and execute the code appropriately. Of course, this is one way of doing it, but it works pretty well. What if there is a need to chain together multiple functions within an API? Many times there is a lot of interdependent functionality going on. So AWS does offer an orchestration service known as the step functions, which itself is a serverless offering. Once the step functions comes up, it will invoke other microservices or steps, in this case, one after another, as needed in the current context. Based on the execution status of previous microservice, it will continue with the steps. And once all the steps are done, the orchestrator will shut itself down. Now, some of you may be thinking, well, the microservices look great, but my app is a monolith and I cannot really break it down into microservices. This is not going to work for me. But my app only runs for a couple of hours each day and it sits idle for the rest of the time. Are there any serverless computing options for me? Well, yes. AWS offers a service called Fargate that is suitable for these types of scenarios. Fargate essentially spins up compute resources based on a previously built and registered Docker container definition, then loads the Docker image from the container store into a newly spun up compute resource, executes the appropriate code based on the task definitions. Once the task completes execution, Fargate will shut down and terminate all compute resources. And you will only be charged for the time and resources that you utilized during this whole process. This picture here is a reference from the AWS documentation explaining how Fargate can work for you. Now, Fargate utilizes Elastic Container Service, Elastic Kubernetes Service. It is a lot more complex than this simple explanation. We will do a separate tech brief video where we will get into the details of AWS Fargate service and how it works. We have seen what serverless computing is and what it can do at a very high level. Let's talk about why you should think about using it. If you really think about it, there is only one fundamental advantage with going serverless over other approaches. And that benefit is the fact that you do not need to concern yourself at all with hardware provisioning. That's really it. But don't underestimate that benefit though, because it can have huge impact, positive ones, on costs, time to market, and ease of deployment depending on complexity of your system. There are also some indirect benefits too going serverless, especially because microservices architecture forces you to think in terms of MVPs and building up capabilities incrementally because you can, rather than the tried, tested, and failed age-old boiling the ocean approach. What costs can you save by not worrying about hardware? Well, hardware procurement can be a big process in some companies. Not worrying about the hardware means no procurement, no provisioning, no configuration, none of that. Saving money and time. There will be networking and other environmental costs for running on-prem data centers. This may not be as big of a problem for cloud, but you may still need to set up some virtual private clouds, VPCs, or subnets and such. In serverless, no worries. As we all know, owning hardware comes with the greatest responsibility of maintenance and upgrades. This can cost some huge money for on-prem. Cloud may or may not have this issue if you decide to go with managed services, but serverless, no worries. Now, what about the usage costs, the costs of running the application? Well, in on-prem and cloud models, you already paid for the resources, the computational resources, the hardware. So you don't really pay anything extra for running the application per se. In serverless, though, this is actually the only cost that you would really incur because you pay when you use the service. And so you usually build up, when designing systems, we usually build up the infrastructure so that we can support the peak demand, peak loads. But we don't use all that hardware resources all the time. A lot of it sits idle while waiting for demand to shoot up. In serverless model, you only pay for what you use and when you use, so no idle infrastructure. And you do over-design for high availability and failover systems too. You do need to keep in mind for serverless, so this is a concern for any system. In serverless, you do have to keep in mind that there are limits on how much it can scale, and there are going to be some rate controls because of when you hit the limits, and some of the lambdas will actually respond back with 429s. And when this happens, how does your API respond? So those are the things that you may have to keep in mind and architect in such a way. And in many companies, you will have, of course, different environments, right? The dev environment, QA environment, UAT, staging, and prod, obviously. So now multiply all these costs for each of those environments and see how much cost savings you can have. Serverless nicely integrates with many popular CI/CD pipelines, continuous integrations, continuous delivery pipelines like GitHub Actions, Circle CI, or AWS's own offering, the Amplify service, where you can run automated sanity tests on the services before they are deployed to any environment. One big advantage of microservices architecture is that the code is refactored into small single-purpose building blocks, And these can be deployed through CI/CD pipelines, one piece at a time or all at once, as you choose. Of course, there are more benefits going serverless. A huge benefit is that you will significantly improve the time to market when you're focusing solely on building business logic, rather than spending your time and energy worrying about the hardware needs. This is the single biggest reason why SMBs, the small and medium businesses, and startups should strongly consider this technology. We have talked about this throughout the presentation, but autoscaling to peak demand is a good benefit to have. Of course, there are limits with serverless, as we discussed before, and you have to architect for those. And also, since you're on the cloud, you can leverage the ease of integration with other cloud services like messaging, notification services, and data streams, and others. What problems and scenarios is serverless technology best suited to solve? If you have a new product idea and want to validate the idea very quickly by building a quick prototype, definitely try this. Try serverless for this scenario. If you have bursts of traffic and there is you need auto scale, and you may or may not know all the infrastructure requirements for this, try serverless. And if you're ever doing any legacy system transformation and going modern, moving to cloud, or re-architecting the whole landscape, a great idea to consider microservices as well as serverless, if that fits your needs. Startup company, enough said. Your primary focus should be on building business logic and staying afloat for the remainder of the year, not worrying about hardware needs. When you see a promising new technology, the tendency is to use it to solve any and all of your problems. May not always be a good idea. Let's see places where serverless may not be that appropriate to use. If you have a content-heavy or UI-heavy front-end application, serverless may not be the right answer. There are other options for front-end hosting, such as S3 hosting combined with CloudFront for CDN-like edge computing. Or let's say you have an very simple e-commerce storefront with very basic catalog. A framework like Shopify will more than address your needs instead of serverless. On the other hand, if you're building an omnichannel commerce application with integrations to multiple systems like ERP systems, shipping systems, and others, serverless technology can be a great solution for you. Serverless usually works great for applications with burst mode traffic, burst mode demand. But if your application is continuously running, there are better options to save money. For example, you can prepay for your cloud infrastructure and save more money that way if you know what hardware resources you need. Finally, if you have managed services, you can just relax unless there is a need for a new product line. Great. So where do we go from here? Let's say serverless is the right choice for you and you want to start implementing it. What are the next steps that you should take for implementation? Well, first you have to see if your product fits the microservices model, and if it doesn't, can you utilize the containerized serverless model? Next step is to choose your cloud provider. You can use either AWS, GCP, or Azure. They all have similar implementations, and they do offer some free tier offerings which you can leverage during the prototyping or initial growth periods. And a backend language for implementing your APIs. Python and Node.js are definitely the popular choices, but many other languages like C#, Java, Ruby, and others are also supported. Using a framework makes a big difference in productivity. Serverless framework is YAML-based framework. It has got great community and it is very easy to use. AWS CDK is gaining popularity recently. It is AWS specific only though. Biggest advantage for serverless framework is its support for multiple cloud providers really. For database needs, AWS does offer a service called DynamoDB, which is a serverless NoSQL database. If this type of database, the NoSQL database, works for your application, you should strongly consider it. Integrating with a good CI/CD pipeline can make life very easy, especially when your project starts growing. So this should be a consideration. It may be optional in the very beginning. Last but not the least, choosing the right architect and implementation partner for your project is of vital importance. Along with cloud expertise, you will need functional and business experience, since serverless computing is all about organizing business logic into small pieces and implementing it efficiently. We do offer consulting services. Please see description for details on how to reach us. Finally, thank you for making it this far, and please stay tuned for more exciting videos. Again, please like, share, comment, subscribe if you got any value from this video. Thank you.